square root of a complex number. So if you have to write down the square root of a complex number a plus ib, so usually you can give two answers for square root. So write it as plus or minus x plus iy. So we'll derive a formula for this. To square it on both sides, you get a plus ib equal to x square plus I square y square plus 2ixy. Since I square is minus 1, you can write this as x square minus y square plus 2ixy. And usually when two complex numbers are equal, we can equate real part with real part. So we get a as x square minus y square, imaginary part with imaginary part. So without I, you have b here, and without I, what you have 2xy, you can equate them. So this is same as x square minus y square equal to a, and this is same as 2xy equal to b. Call it as 1 and 2. With the help of this, first let us write down x square plus y square whole square. We know that a plus b whole square equal to a minus b whole square plus 4ab. So 4x square y square here, because I am treating x square and y square as a and b. So this will be a square plus 4x square y square is square of this, which is b square. So from here, you can conclude that your x square plus y square, generally you make it plus or minus, but we'll write only plus because if x and y are real numbers here, x and y are real numbers, when you square and add two real numbers, you cannot have negative. So therefore, it will be just positive only. We'll skip the minus sign. And once you get that first and third equation, you see, you know, x square minus y square is a from one of them, and x square plus y square is known from other one. From 1 and 3, you can find out the value of x and y. So how to find x and y from 1 and 3? So from 1 and 3, you add them, what do you get? 2x square is equal to root of a square plus b square plus a. And if you subtract them, you'll get 2y square equal to root of a square plus b square minus a. From here, you'll get x and y values. Substitute this here, you'll get the square root of the complex number. Okay. So just put these values of x and y here and find the square root. So I'll just leave it to you for simplification part. You can find x and y, you'll get a root, put it here. And if there is a minus ib, here in between, you'll put a minus sign. So that's how you find square root of a complex number. Now let us begin with some questions on the first topic of complex numbers. So here we have the value of the sum where I is root minus 1. Let's solve this problem. So if you observe, that sum can be written as, if you put n as 1, it is I plus I square. N as 2. So if you put I as n as 1, it is I power 1 plus I power 2. N as 2, it's I square plus I power 3. So like this, you'll get a summation. So when you have to combine, some terms are repeating. So the better way would be, actually we'll take out something common. That would be easier instead of doing this. So what I'll do, let us take I power n common. So n equal to 1 to 13. If I take I power n common, inside you'll get 1 plus I. And since in sigma only n is changing, 1 plus I can be taken out. And you can just write that as sigma I n equal to 1 to 13. And 1 plus I was removed already. I power n is remaining. So that is same as 1 plus I into, if you write down the powers now, I power 1 plus I power 2 plus I power 3 plus I power 4 and so on up to I power 12 plus I power 13. So we have a property that whenever you add 4 consecutive powers of I, the sum is always 0. So from 1 to 4, it will be 0. From 5 to 8, it will be 0. Like what I'll do, 1 plus I into. So if I write down this 1 plus I square plus I cube as one group. Then I power 4, I power 5, I power 6. This is starting from I, sorry. I power 1, I power 2, I power 3. I power 1, I power 2, I power 3, I power 4. So let me write here. I power 1 plus I power 2 plus I power 3 plus I power 4 as one group. This sum would become 0. And then next, then we have I power 5, I power 6, I power 7, I power 8. This 4 will add to 0. And similarly, I power 9, I power 10, I power 11 plus I power 12 is one group. I power 13 will separate out. So any 4 consecutive powers of 5 will always add to 0. So this sum would be 0, this would be 0, this would be 0, and I power 13 would remain. So we'll get 1 plus I into, everything would be 0, just I power 13 would remain. And how do you write I power 13 as? We can actually write I power 13 as I power 12 into I. And since you know that I power 4 is 1, I power 12 will be I power 4 whole power 3, which is also 1. So we'll get 1 plus I into This is anyway 1, so you'll just get I. Multiply this, you'll get I plus I square. Since I square is minus 1, you can write the answer as I minus 1. So now if you look at the options, B is the right answer. This was quite simple. Now let's move on to the second question. The complex number where n belongs to z is equal to. So we have to simplify this and match with the options. So the first part, if you see 1 plus I power 2n, I'll name that sum as s only, 2 power n by, I can write 1 plus I whole square whole power n. And the second one is again 1 plus I whole power 2 whole power n by 2 power n. So this is 2 power n by what is 1 plus I whole square. This is here actually. So you'll get 1 plus I square plus 2I power n. And second one, 1 plus I square plus 2I whole power n by 2 power n. So this is same as 2 power n by, since you know that I square is minus 1, actually this 1 and minus I square will cancel because there is minus 1. Similarly, here these two will cancel. So denominator is 2I power n and here numerator is 2I power n. So we have 2I power n here. And here we have 2I power n by 2 power n. So this is 2 power n by 2 power n into I power n, and this is 2 power n I power n by 2 power n. So let us cancel 2 power n from here. So we'll get 1 by I power n plus I power n. But if you look at the options, you have I power n in numerator. So how to get I power n in numerator? So we can actually multiply numerator with I power n, denominator with I power n becomes I power 2n. So then I power n is common in both. You will get 1 by I power 2n is nothing but I square power n, which is minus 1 power n plus 1. And whether you write minus 1 power n in numerator or denominator doesn't matter, because for odd power it will give minus 1, for even power it will give plus 1. So it doesn't matter whether you write in numerator or denominator. So if you write in this format, so clearly you can see that C option will match. Okay, I hope that's clear. Now let's move on to the next one. If a plus ib power 5 is alpha plus I beta, what is b plus ia power 5? So if you are given a plus ib power 5 is alpha plus I beta and you want b here, you want b without I. So take I common. So before that, what you can do, you associate I here. That is right. Before this, you write I square, which is minus 1, and write a minus sign. Then it's same as plus A only. Right hand side will write as it is. Now you can see that in both the terms, if you take I common, you'll get b minus IA. And whole power 5 is there. So power 5 for this, power 5 for this, you can write separately. And what is the value of I power 5? I power 5 is basically I power 4 into I. Since I power 4 is 1, you can write I itself. So this is I into b minus IA power 5 is equal to alpha plus I beta. Now, if I had to remove this I from here, you can multiply both sides with minus I, because if it is I into I, it is I square, which is minus 1. But I want to get plus. So if you multiply with minus I, LHS will become b minus IA power 5. And in the right hand side, if when you multiply minus I, it is minus I into alpha plus I beta. So this would be same as minus I alpha minus I square beta. Writing I square as minus 1, this will become beta minus I alpha. So if this is b minus IA power 5, we have a rule that if two complex numbers are equal, if Z1 is equal to Z2, then their conjugates are also equal. So using this rule, you can say the conjugate of this is b plus IA power 5. Whether power 5 is there or not, it's still applicable. And you can apply conjugate, you'll get beta plus I alpha. So the required value is beta plus I alpha. That is, first option is the right answer. Okay. Right. Let's move on to the next question. So we have to find out the square root of this with positive real part. So if I have to write down the square root of a plus ib, so we already derived the result. The formula is plus or minus root of a square plus b square plus a by 2 plus I times root of a square plus b square minus a by 2. This is the formula to find square root. If there is a plus, you will write plus here. If there is a minus here, you will write minus here. So if you want to include that, you can include here only, plus or minus. Now, the given sum can be written as root of minus 3 minus 4i plus root of 3 plus 4i. Suppose you take minus common here, then this is root of minus 1 into 3 plus 4i. And since square root of minus 1 is I, you can write I times root of 3 plus 4i here. The second term will write same. So that is plus root of 3 plus 4i. Take this common, then you'll get I plus 1 into root of 3 plus 4i. So now using the formula for square root of complex number, you can actually write this as plus or minus root of a square plus b square. So here a is 3, b is 4. So a square plus b square in this case is nothing but 25. So root of a square plus b square is root 25 plus a by 2 and plus root of a square plus b square minus a by 2. So let us write that. Then this will be 1 plus I into plus or minus of 5 plus 3, 8, 8 by 2, 4. So root is 2. And here 5 minus 3, 2, 2 by 2 is 1. So root 1 is 1. So there will be an I term also before this, plus or minus 1i. Because in the formula, there will be an I term here. So you have to write I also. And write plus or minus outside, multiply 1 plus I with the 2 plus I. So that plus or minus is not required here because you already wrote outside. So 1 plus I into 2 plus I. If you multiply this, you'll be getting plus or minus of 2 plus I plus 2i plus I square. And writing I square as minus 1, this will become plus or minus 1 plus 3i. And they have asked us to find out, take the value of square root with the positive real part. So out of these answers, so there are two answers here, 1 plus 3i and minus 1 minus 3i. So if you want positive real part, the answer is 1 plus 3i. So we can mark C option because you wanted the real part to be positive. Minus 1 minus 3i is not in the option, and anyway that doesn't have positive real part, so we'll have to mark C as the answer. Okay. So let's do this problem now. The complex numbers are conjugate for what values of x? So if they are conjugate, the first one is suppose z1 and the second complex number is suppose z2. So they are saying their conjugate means z1 is same as z2 conjugate. So sin x minus I cos 2x equal to conjugate of z2 means you'll write I as minus I, so you'll get this. And generally when two complex numbers are equal, we can equate real part with real part. So sin x will equate with cos x. And imaginary part will equate with imaginary part. So the coefficients, if you equate for I here, you'll get minus cos 2x equal to sin 2x. So clearly you see that this will give you tan x as 1. And this will give you tan 2x as minus 1. So if you find a value of x here, from the first one, x is pi by 4. In the second one, if you write tan 2x equal to minus 1, if you put pi by 4 here, you will get tan 2 pi by 4 equal to minus 1 or tan pi by 2 equal to minus 1, which is not valid because the value of tan 90 is not defined. They are not equal. So there is no common solution because this to be conjugate, these two should hold together. This should hold and this also should hold. So therefore, answer would be no value of x because the value of x that you got in first one is not satisfying the second one. They don't have a common value. So therefore, they are not conjugate of each other for anything. So D is the right answer. Okay. So with this, we have completed the algebra of complex numbers. So for the next session, we'll be doing the concept called modulus and argument for complex numbers. Okay.